welcome to Chapter 5, Section 8. This is a section called Direct Variation. Now, this is a little bit different than we have been dealing with. I think it's a little easier. I don't understand why they put it at the end of the chapter. So, you get to relax a little and say, oh, okay, I get a break. Because it's definitely not as complicated as the last chapter we had, or the section we had. So, direct variation means that you've got your y and you've got your x and you have a constant. And what that means is you take your x and you do one thing to it and you do the same thing to it each time to get your line. So this is a times 4 or divided by 3 kind of thing, always, always. It's not like we've been dealing with. There is no plus or minus b ever. This line always goes through the origin. Y equals some number x. And yes, this is your slope, but there's no ever plus or minus b ever, ever. Now, you can mess with this. You can say divided by x, and these go away, and you can say k equals y over x. These are the same equations. So just because it doesn't look exactly like y equals kx doesn't mean it's not exactly like y equals kx. If you've got something that either starts with an x or starts with a k, you want to manipulate that equation by multiplying or dividing whatever so that y is always by itself. For example, this equation, you've got a 2 multiplied to your y. You want y to be by itself. How are you going to fix that? You're going to divide this by 2. You're going to divide this by 2. Now this goes away and you've got y equals something. What do you got? This is actually y equals 1/2 x. Do you see how if I divide x by 2, it's the same as multiplying x by 1/2? Divided by 2 is the same as multiplying x by 1/2. Now, that looks just like that. And I can tell you that my constant is 1/2. How about this one? Can I make this look like this used to look? Well, I'm going to subtract 1 from both sides. And that goes away, and I end up with y equals 2x minus 1. No, this is not a direct variation because I've got one of those, and I'm not supposed to have one of those. So that's not a direct variation. What about these? Here I've got some tables. Do these vary directly? So here's my x's and here are my y's. So what am I doing here? Y is going plus 3, so I've got y equals 3 times x, n doesn't matter. And what do I have to do to get from my answer to this number? Well, 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. So I don't have any number I have to add or subtract. So this is a direct variation. How do we use direct variation in a word problem? Here's our example. An eastern box turtle walks 18 feet per minute. There's our rate. 18 feet in 1 minute. Write the direct variation equation. Well, I know that our distance, however far this thing walks, is going to be 18 feet times however many minutes he walks. And that equation, if you write down the numbers for what I just said, the distance, which is really y, is 18 feet times however many minutes we're talking about, which is really x. So here we've got our equation, y equals 18x. This is our direct variation. How do we graph this? Graph the data. Well, time always goes here. So let's try after 1, 2, 3, 4, 5 minutes. And then our distance, 18 feet. So every time he goes up, he's going to go 18. So let's go up by tens. 30, 40, 50. up by tens. So, oh, and we're going to label this distance in feet. And this is minutes. All right. So, he goes 0 feet in 0 minutes. After 1 minute, so let's make our data table. X, 18x, y. 1, 2, 3, 4, 5. 18 times 1, 2, 18, 36, 54, 72, 90. And we're going to graph this. 18, 36, 54, 72, which is way up there, and that's what our graph looks like. How long does it take an eastern box turtle to go 162 feet? Well, here's one of those things where I could do my repeated addition and be a child about it, or I can say, okay, the distance is 162 feet. I want 162 feet to be my answer, and that's going to be 18 times how long? How long? So the time is the question. Times what? Well, 162 equals 18x. If I divide each side by 18, that goes away, and my minutes, my x, equals 9. It takes 9 minutes for a turtle to go 162 feet, if you can keep the turtle interested that long. Most of your direct variation questions are going to be about distance and time. So I need you to be able to find your distance and your time. This is your rate, feet, how many feet per minute is going to equal your distance. I need you to be able to set up a problem that looks like this, okay? So here's your chance to practice. Now for these, the question is it direct variation? And if yes, if it is, what is the constant? And the constant is k. What is that extra number? Whereas where in the last one we had y equals 18 times x, 18 was our constant. What is our constant here? So you've got y equals x over 7, which is really 1/7 x, remember that. You've got 3y equals 15 minus 6x. Switch these around, take the negative sign with you, and then divide everything by 3 and tell me if this is a direct variation or not, and if it is, what's the constant? And then do this, and tell me if this is a direct variation or not. Next, Neil Armstrong's weight on the moon was about 1/6 of his weight on Earth. You're going to write that in a direct variation. You're going to graph the data just like we did on the last page. And I'm telling you that Lou, Neil's friend, would weigh 24 pounds on the moon. How much would he weigh on Earth? 24 pounds on the moon. Now, is that y or is that x? Plug that into your equation and then solve for the missing variable. Okay? Now, remember how to read word problems. Weight on the moon was, here's your equals, 1/6 weight on the Earth. So you have one variable equals 1/6 of the other variable. So write your equation that way. Okay? Good luck. Put hazard signs where you need to. Give this an honest try because you're going to have homework problems like this. And it's not that bad if you can translate into math and then work the math. Okay? Good luck, and bring any questions you have to me, and I will see you tomorrow.